All right. Hey, everybody. Thanks for sticking around for the last talk of the day. I'm sure you're all exhausted by now. So like he said, my name is Keith Smiley. I am an iOS developer at Lyft in San Francisco. If you're not familiar with Lyft, we're a ride-sharing company primarily in the US, but you can actually use Lyft here in Singapore too, because we have a partnership with the local company Grab, who's also a sponsor here, to where you can use the Lyft app and request a Grab, which is really nice for users who travel to Singapore from the US and are used to using the Lyft app. So today I want to talk about using Swift protocols and specifically protocol extensions, how we use them at Lyft to write like reusable components to kind of try to keep small portions of our code like in nice individual testable pieces and keep them out of the view controllers as well. So before I get too much into that, I kind of want to disambiguate what I mean when I say protocols. As iOS developers, I'm sure when I say protocols, you can think of a lot of places where you've used protocols in the past or where they make a lot of sense since they're super flexible. They're all over Apple's APIs. So I want to talk about two main uses that aren't really related to what we're actually going to talk about today. So the first use of protocols that I'm sure everyone is familiar with is just protocols that I would categorize as being for general loose coupling in your development. And by this I mean some simple implementation defined in a protocol that you conform to in order to get behavior from some other class where the two types don't particularly know much about each other. A good example for this that I'm sure most of you are familiar with is UI table view, delegate, data source stuff. These are all over Apple's frameworks. Here's a short list of some of the ones that we use in our app, and now we can use the new UN user notification center delegate, stuff like that. So I'm sure many of you have seen this. This is a super important, useful category for protocols, but not really what we're going to talk about today. Another really common use for protocols is just for writing general polymorphic code. And instead of trying to read the Wikipedia definition or something, polymorphism, I'm going to show a quick example. So we have a screen that looks like this in our app for when you're in a shared ride. So a ride where you're a passenger and then also someone else can be a passenger too. And you can see that we have this collection view across the bottom that shows your image and the other people in the car's image and the name and stuff like this. So you can probably think about how you would implement setting up that collection view cell for this information. You'd probably have some display function that looks something like this. You'd pass it a user, you'd take the properties from the user, assign them to the label, download the image, whatever. And this, seems all right at first glance, but then if you think about it in this context, the context of this specific feature, it doesn't really make sense. So imagine that we have some struct like this called a user, and this represents current user using the app. So if you're using the app, it represents you. And we have some general information about yourself, some public stuff, like your first name that obviously the other passenger sees, and the URL of your photo or something like that. But then we also have some private information about you, like payment methods or phone number or some other stuff that you don't really want all of the other passengers you're in the ride with to be able to have access to. So of course from our server we don't get a ride model that looks like this, where you'd have an array of users or something, because we don't want to leak that information. Instead it looks something like this, where we have a different struct somewhere called a passenger that has fewer properties. And it has some overlap with the user, like the name and the photo URL, but not a ton. And now, obviously, our display function from earlier doesn't work because you can't pass a passenger as a user. So this is where we pull in a protocol to encapsulate this information. So we define some protocol like passenger representable, named that way because this is the interface necessary to be shown as a passenger in our UI. And then we add these two simple properties for our use case. We make our user struct conform to that. We don't actually have to change anything here since we're using the same property names and everything. And then, we conform our passenger struct wherever that lives as well. And then finally, we'd, update this display function to use passenger representable instead. And, this allows us now to set a user or a passenger or anything else that conforms to this protocol without having to duplicate display functions per model that we want to be able to display in this, reusable collection view cell. And another benefit of this is, you can reuse this passenger representable protocol all over your app, wherever that abstraction makes sense. For us with this specific example, we use it all over the place because we have tons of this use case where you're showing you and someone else in some UI. So I'm sure you've seen kind of examples like this in Apple's frameworks or in your own code, where you kind of encapsulate shared information in protocols like this. But today I mostly want to focus on an entirely different use for protocols that only really made sense once protocol extensions in Swift existed. But But before that, so if you aren't familiar with what we did at Lyft, about a year and a half ago, we shipped an entirely rewritten version of our app in Swift, which doesn't sound as crazy today, I don't think, because the community is obviously very involved with Swift. Everyone's really excited about it. Most new apps, it seems like that you hear about are being written in Swift. Swift 3 shipped. It's like the language has evolved a lot over the past few years. But if you remember kind of the earlier years of Swift, you kind of have to like change your mindset to think about this, because since we shipped our app like a year and a half ago, we were writing Swift over 2 years ago before Swift 1.0 was released to the public. And we actually have code that was written pre 1.0 that's still in the app. Of course, it's gone through lots of syntactic changes, but we still have code like that there. And I'd say that up to this point, like protocol extensions have been definitely the best addition to Swift. But before we get into kind of how we use those for how we use them at Lyft, I want to talk about just kind of general code reuse before protocol extensions were added. So let's assume that you got like a mockup or something like this. These are 3 screens from our app, and you want to start thinking about how you're going to implement this. So obviously, these view controllers are pretty similar. They all have the map. They share some buttons and headers, and they all have a button across the bottom. It's a different color and stuff. But you have the footers. They look kind of similar. So you can think about how you might implement this, before protocol extensions or in Objective-C or something like that. And so maybe something you would do would be like create some base view controller like this, where you have some outlets and some actions that you want to kind of unify for shared behavior. And then, you'd create a subclass maybe of your view controller for that first one on the left, and you'd set up the outlets or override the next button tap function to kind of do whatever you want. So far so good, I guess, depending on how you feel about view controller inheritance. And then, you'd subclass it again for the next view controller and like override it, do something different. Probably eventually your app would, like the different screens would kind of diverge, and then maybe it might get a little hairy because, your base view controller would have properties that you were only using in some subclasses and not others, and then the abstraction kind of falls apart. But we're not there yet, I guess. So then for our third view controller on the right, it looked very similar to the second one. So maybe we would do something like this, where the only difference between those 2 view controllers was like the ride type you were requesting. So maybe we'd add a new property to our request one, and we'd subclass that again, change the property, and then kind of share the rest of the behavior between the two. Or maybe you decide you want a different functionality, so you'd like override this next button tap function from your super class, but then you don't call super in the implementation or something because you want to do something entirely different. And now I feel like what you have is kind of a mess, because you can't really change the request view controller anymore without being worried about breaking the request plus view controller, since you don't know like what behavior it depends on unless you understand it entirely. And even worse, you don't know what bugs it depends on. So you can't even just like go in and fix a bug in the request view controller without worrying about breaking the request plus view controller that depends on that. And you definitely can't change the base view controller anymore, because now you don't know how it affects like the request plus, request, and idle view controllers. And of course, also, this is only 3 screens, right? So like in our app, we have 200 screens or something. So depending on how many classes you have inheriting from that base view controller, how far this chain goes, it can get really messy. And before Swift 2.0, there weren't any other like big major language features to combat this. And of course, before anyone yells at me, of course you could have architected this differently. I would advise everyone probably against using view controller inheritance in general. It's a different conversation. But you can see here that we kind of have to be careful before it gets kind of complicated. And that's how you kind of get into a situation like this. So this is a class graph of like all of the main view controllers in our app from before we made any protocol-oriented refactors. This might look kind of daunting, but it actually wasn't that bad, because at the time, all of these view controllers were all less than 300 lines of code, and the inheritance mostly made sense. I mean, if you can read some of them, you can see like the passenger and driver stuff are kind of separated, except for their, the top level and stuff like this. It made a lot of sense at the time. But imagine if these view controllers were like a few thousand lines of code instead of a few hundred lines of code, because then it would be much more unmanageable. And even at this size, it was still extremely difficult to deal with. I guess when we wrote this, we probably had 10 or so developers working on the iOS app at any one time. And then as we started scaling up the team, it got a lot harder, because fewer developers understood everything that they could break by changing one line of code. And the further you go up in this graph, the more likely you are to break like the entire app by making a small change. So this wasn't really sustainable long term. And of course, this is where protocols come in. So after Swift 2 went public, since we shipped at like Swift 1.2, we kind of thought about doing a refactor, and our goal was to, break up the functionality from all these view controllers and all the inheritance between them into reusable, kind of focused protocol extensions, that we could pull in as components to, all these main view controllers in our app, and also anywhere else in our app where it made sense. And of course, as a side effect, this means that it would keep our view controllers smaller because all the logic was living in these protocol extensions instead of in the view controllers themselves. But before we kind of look at that, how that cleans everything up, I think it's worth thinking about what makes sense to share from our original example. So, I intentionally made this example, maybe not the best, but it's not really useful to share like outlets between a lot of view controller levels of view controller inheritance, right? Because unless you have a lot of very complex layout code or something, which I hope you don't, I hope you're just using auto layout, then you're not really gaining anything except for maybe saving one line of code between these. And I actually think that, sharing this action is actually worse for everybody because if you notice through all the slides previously, we always had this action named next button tapped, which is like a super generic name that doesn't really explain anything. But from our base view controller, we don't know anything more about what that button is going to be used for, so we can't actually give it a much better name at all. And I think this brings us to an important idea that's worth keeping in mind. So I think this quote is really interesting, and I think it's worth thinking about no matter what like language or platform you're working on, but I think it's particularly applicable here because all of the issues we kind of saw in those last few slides were all inheritance problems caused by attempting to avoid duplication at all costs when that wasn't always really the best course of action. So I would argue that duplicating more simple code can leave you with a better final like readable, maintainable product. So I think we should keep that in mind for the rest of the talk, and we'll look at some of these. So with that in mind, we can think about what would be worth sharing between these two view controllers that kind of do the same thing. Here earlier we added this property to do this different ride types, and then maybe that next button tapped would have actually requested something based on that property. And I think this probably makes sense to share like the logic for requesting a Lyft and handling errors and doing the networking and stuff like that. Because if you think about it, like even from a product perspective, if your user experience is massively different when all your user wants to do is request a car of like a slightly different size, it seems like something probably went wrong there. So I think this is fair to share. So let's look at how we can share that using protocols. So we can define some new protocol like this called ride requester. The name might sound a little funny, but you should think about this as a protocol that's defining the ability to do something. So a type that can request a ride, therefore, is a ride requester. I don't want to get too into the weeds on naming, but there's some documents online, and Greg Kyo did a talk at Swift Summit last year about like how Apple chose to name all their protocols based on what they do and how they work. That's worth watching. So you can kind of think about that when you're implementing your own protocols. I have some more naming examples later as well. But so with this new interface, obviously we haven't filled in this function. We kind of need to think about what it means to request a Lyft. And for our example at least, we'll define a function like this where, what it means to request a Lyft is that you've chosen a ride type, maybe you have a pickup place and an optional drop-off place depending on whether or not that's required. And then you have this completion closure that, either gives you a ride or an error depending on what happens. And obviously up to this point, nothing has been different from like pre-Swift 2.0 or anything. And if we stopped here, we wouldn't have really solved any of the original problems. Because if we were still like, doing this view controller subclassing, we could use this ride requester protocol, we could implement it, maybe we'd call, super from the subclass or we would override it ourselves or something like that. But remember that like part of our goal here was to remove all of the like incidental complexities introduced by inheriting tons of view controllers and everything. So this isn't a great solution. And neither is it if you weren't even sharing the superclass of request view controller. So then view controllers would have to implement this function themselves, and then we'd have to duplicate that logic, which we decided is worth sharing. So there's really no win here either. And of course, this is where we finally get to protocol extensions. So here we've defined a protocol extension on our ride requester protocol that actually defines default implementation for this request Lyft function where we can do like all of the work. And for us, this could mean validating the user's input on the client side, like can you actually request a ride wherever you're trying to, or can you get dropped off wherever you're trying to, or something like that. Or it could just mean creating the request, sending it to the server, and handling the errors when it comes back, maybe showing some modals or something like that. But the really big win from this comes when we go back to our view controllers with this new implementation, because now we conform to this new ride requester protocol, and we just have this behavior for free in our view controllers without any unnecessary duplication, which is great. And also here, I've renamed the IB actions because now we can make them kind of make something that makes more sense since we're not inheriting view controllers as well. So for those of you who've used Swift protocol extensions already, this probably isn't much news, but also you might ask, what if I just override or implement the request Lyft function from my view controller instead? Aren't we back to kind of the same inheritance mess that we saw before? So you could definitely do this, where you conform to the protocol, but instead of using the default implementation, you decide that it's a good idea to go and implement your own version of this function. But I think it's worth thinking about what kind of damage you could do to the rest of the app here, because we saw in the inheritance chain that there are a lot of problems that could arise. So here you're opting out of the default implementation, right? But it's really it's a either-or situation. So you can't call super from this in order to call the original default implementation from ride requester, meaning that there's no way you can get into the situation where you have like 5 levels of nesting before you can actually understand what the function does. And this also means that even if you decide to do this as a member of your team, I could go into the ride requester protocol, I could go into the extension, I could change anything that I wanted to, and it wouldn't break whatever your crazy implementation happened to do. But let's also remember that we're thinking about these protocols slightly different from the delegates and the polymorphic protocols that we were talking about before. So there's really no benefit in even sharing the conformance if you don't want to opt into the default behavior. And here I've just removed that and changed the name and everything. Because it doesn't really make sense, at least in this case, to pass around a ride requester as like a generic interface. So instead, you can just toss this protocol conformance entirely. You can change the function entirely, the signature, you can add parameters, whatever you want to do. And if it's truly a one-off case, this might make sense. And no matter what, you're definitely not interfering with all of the other consumers of that protocol, which I think is the most important part there. So I want to show a few more examples of how we use protocols by breaking down one of the more complex screens in our app. So this is the first screen you see when we're logging in. This is the one we saw at the beginning as well. And it actually does a lot. It's probably not the most complex UI you've ever seen. But when you start seeing how many states this screen has to handle, it can get a little bit crazy. And our goal here, remember, is to kind of break down reusable pieces into different protocol extensions so that we can reuse them across lots of view controllers. But I want to go through a few of the states that it can be in so you can kind of get a sense of how much complexity there is here. So here's the first few. If you've used our app before, you've probably seen some of these. So it can show like any number of modals, like these left two, permissions ones or the informational ones like this, or we can show modals for promos or anything that the server sends. They can literally send a URL that gives us some HTML and we'll display that, whatever you want, whatever they want to do. So there's a lot of stuff going on there. And then, we have a slightly different highlight on the right where, the first time you open an app after we add a new feature, it calls out this button or something like that. You can probably think about how to implement most of these in a manageable way. Here's a few more states we can be in. So these are all related to a feature that we have called venues, which is we can draw geofences around points of interest in order to constrain passengers to specific pickup and drop-off positions, which is super useful if you've ever been to a airport in the United States, because there are a lot of restrictions around where users can get picked up and dropped off at the airport. So this allows us to guide the user through the UI to the correct experience without them having to call their driver and try to figure out where everybody is. So, this first screen, it looks pretty similar to the last one we saw, except that it, removes all the UI from behind it. And it's not really calling out a specific thing. It's also specific to a venue. In the background, you can see these dots and this polygon drawn around here. The second screen, we have a little tooltip and stuff, and we have some more dots and stuff like that. And then the third one's kind of an interesting case where it's actually defines an area where you can't get picked up by Lyft. So we have this weird red shape that's restriction, and we disable some UI and stuff like that. And there's a tooltip and stuff there too. So that's some more states. I hope you can see kind of how this can get kind of complicated, because remember, this is all one view controller handling all these states. And we have some more too. So you can have some generic banners across the top where you can't get picked up at Market Street. And then tapping those banners can open modals like we saw before. They can do deep links or tons of different stuff. We have some empty states where we change the pin and put some text and disable some buttons. And then obviously this isn't the same view controller where we're showing this play search thing, but it does handle showing it. And then if you choose something, it handles updating the location and moving the map and all this stuff. I think this is most of the states that this view controller can be in. But as you can see, it can do a lot of stuff. And if we're not careful about how we implemented this, you can see how it kind of end up in an unmanageable mess of if statements or something where you're handling every single state and you're like clearing states as you switch between states or something crazy. So we actually separated the logic for this ViewController into like a few dozen reusable protocols. I want to look at a few of them now. So this is kind of the simplest state that you can be in an app. It's actually, you can't actually get to this, but this is just kind of to illustrate our view hierarchy. So we have a map, obviously, in the back of our, like the top level of our view hierarchy. And it turns out these maps take like a half a second to be loaded into memory on like on a 5S. So if we were, creating a new map every single time you went back and forth in the UI, it would be like a really jarring user experience. So all that is just to say that we can only use one map throughout the entire flow of the app, which means that we've actually implemented all these other view controllers as child view controllers that get placed on top of the map in order to do some other stuff, and then we replace those as you move through the flow. And of course, to do this, to tie all these together, we decided to create some protocols to handle this interface. So the first of which we call MapStateDisplayable. We named it this because it represents a view controller that is displayed on the map for a specific state in the ride. A state in the ride for us is like, you're waiting for your driver to come pick you up, or they picked you up, or they dropped you off, or something like that. So we have a separate view controller for every single one of those states, which there are like 20 of. I think the most interesting thing here is this prepare function, where we actually get your view controller would get called on your prepare function would get called before you're actually put into the view hierarchy. It also gives you time to like set up your initial UI state based on the ride that's passed along. And you can also like set up some observers or something like that if you want to, get periodic updates to the ride. And then we also have a, corresponding unprepared to kind of tear those down. And these other two are kind of interesting as well. I really just left these in there to illustrate that, these are for doing custom animations when you're going in or out. Like I said, these are child view controllers, so they get added and removed, and you can do a custom animation then. We don't often do that, but since we're using protocol extensions, we can easily kind of define these as pretty much no ops and then use them when we need to. Obviously, if we weren't ever using them, we wouldn't have them, but we do have some places where you do some crazy animations between view controllers. So all of our child view controllers conform to this protocol, and now we have another protocol that actually handles like the presentation of these. So MapState Presenter takes a MapStateDisplayable, as you might expect, and the ride models and decides whether or not it should like switch to the new state, which isn't always true if the ride hasn't changed. In our case, like a map view controller that we have somewhere is the only user of this, but we tried to model it in such a way that we could easily like swap that out maybe for a different map provider or something like this. Right now we use Google, but if we decided to switch to something else, we could pretty easily swap out the view controller, conform to this protocol, and then everything would work as it did before. And so for this protocol, we also defined an extension that actually does all of the work that's encapsulated in it. So here we're scoping it to UIViewController, which we haven't seen yet, but in our case, this makes sense because we know that this is always going to be a UIViewController realistically, and we didn't really want to introduce much added complexity to handle like the methods that we actually need from UIViewController, which are just like adding and removing the children. I'm hoping eventually UIKit will be a little bit more friendly to protocols so that we could kind of grab just that behavior that we needed, but here's hoping. But the benefit of that means that, down here in this function, if we want to, we can, add those view controllers directly as child view controllers, and even though all we know about this protocol is that we're a UI view controller, which is super helpful. And then with those two protocols and the two implementers of those, we have this screen ready to be displayed. Of course, at this point, it doesn't really, do anything like we saw before, but that gets it on screen. And if you think about this as just a single view controller, it's really not that interesting. But if you think about it in the fact that we have like 50 view controllers conforming to MapStateDisplayable, I think it becomes a lot more useful because we can easily switch between these states by adopting the super tiny interface, and everything else just kind of works. So of course, to implement all of the behavior here, there's a lot more stuff, and I definitely don't have time to mention every single protocol that we use for this, but I want to mention a few interesting patterns that we've used that I think are pretty useful. So the first of which is this protocol we have called Map Observer. So as you've seen, our app is extremely map driven. Like every single screen I think that I've shown has had a map in the background, which means that almost all of our MapStateDisplayables like need to know about user interaction with the map. And this is what that protocol is for. It's super simple. Like this is the entire implementation. And we've defined this function here to start observing, and then it knows how to observe from the map view And then all the view controllers have to do is call this like observe map center did change, and then they'll get called with periodic updates whenever the user interacts with the map, which allows them to like fire network requests to like update the drivers around or pricing or reverse geocode or whatever they really need to do. And it's super easy to adopt because we already have a MapStateDisplayable, so we just throw in the map observer conformance, and then in our prepare function we subscribe to these updates, and then we can do whatever we want with that. I think another interesting tidbit here is this fire initial boolean that we have. We've started using this pattern a lot where so if you saw from our implementation, if we set this to true and there was an initial value, like it would call you with that immediately, which means that we can kind of unify the code path for updates regardless of whether it's the first update or future updates, which has been really helpful for us because that means you can kind of keep this like if statement kind of logic out of your prepare function. And more importantly, when we're using this in 30 view controllers, you don't have to duplicate that anywhere. It lives entirely inside this protocol. We also have a protocol that looks almost identical called Modal Observer that like gives you updates to the ride and stuff like that. And we kind of use this pattern all over the place to get updates from objects without the view controllers having to understand like how they get the updates from the objects. So the last protocol I want to mention, or two protocols I guess, are these feature highlight and highlighter protocols. So as you might imagine, these are used for the screenshot I showed a little bit ago where we have a new feature and we want to like show a view controller and you want to highlight that feature and tell the user how to use it or something like this. So these are two really small protocols. Again, this is pretty much the entire implementation, but it allows us to do something pretty powerful. So first we have this feature highlight, which defines like one of the view controllers used, that pops up and has the information on how to use it, an OK button and stuff like this. And all it has to define is a storage key, which is for us is kind of a lightweight wrapper around NSUser defaults to just make it work with generics. And that storage key just represents whether or not it's been presented. So then from our feature highlighter, which we make other view controllers conform to that can like show these new feature things, it can just check that storage key, and if it hasn't been presented yet, then we show it because we only want to show it the first time you open the app after it's been added. And all that logic lives inside this extension, obviously, which is really nice. And then, again, it's very simple to implement from one of our view controllers. In view.appear, we call this function and we give it the thing to present, and it does it or not based on whether or not we've shown it before. And again, the big win here is that we're using feature highlighter in like dozens of view controllers, and because of this, we don't have to duplicate this bookkeeping logic and handling NSUser defaults and making sure we're doing it the same for every feature highlight across tons of view controllers in all these different places. So I wish I had time to talk about a few more of these protocols and more screens. I couldn't fit the entire protocol graph for any of the stuff that I've showed on here because I think now we're up to over 120 or so different protocols that have extensions that are used for similar kind of behavior. These are all just the ones for that one view controller. But I hope this gives some interesting ideas for how you can like use protocols and protocol extensions in Swift to kind of build reusable components. Like I said, for us, this has definitely been the best feature addition to Swift so far, although we're excited to see what tops it. So that's all I have. Thanks.
Thank you. Any questions?
Hey, good talk. Mic on or?
I don't think so.
Okay, mic's on now. Don't have to yell. Great talk.
Thanks.
What I'm wondering, slightly tangential, is obviously you've seen the app go through the various versions of Swift. How do you actually approach encouraging the team as a whole to adopt all of these new patterns and principles?
Yeah, that's a great question. I think that for us right now, that's kind of an unsolved problem. I mean, we do a lot of like informal stuff to do that. Like whenever WWC comes around, we all like sit down and watch the new videos or protocol oriented programming talks and stuff like that. And then, in code review, if we spot something that maybe it would make sense to be implemented as a protocol extension instead, we kind of, guide people in that way. We also have like open office hours where people can come and kind of like talk about the best way to implement stuff and stuff like that. I think that's kind of like the harder part there is like a social and like knowledge dispersion problem than it is like a programming problem. But that's a few ways I guess we've tried to solve it. Any other questions? Oh. I think it's off again.
Grab engineer here. Yeah. Hello. So I have a question. So I once tried to use a protocol extension to provide some default implementation for the protocol provided by the runtime, by the iOS system. So I realized it's not picked up at the runtime. So, but at that scenario, I really want to provide some default implementation to the protocol provided by the system. Have you ever have kind of solution or experience like this?
I don't think that we are trying to do that anywhere, but I'm not surprised that that doesn't work, especially from the system frameworks. I hope that over time that gets better, but no, we haven't tried to do that yet.
It's a long time ago, I cannot remember the exact scenario. It's like we provide this default implementation given the class is a certain type.
Right.
So it can be useful in some scenario, but just at the runtime, it didn't get picked up.
Yeah, I'm not sure. Classic Swift. Any other?
Can I ask a question? So is there a lot of more advantages compared to the traditional way of doing compositions? So for example, in your case, let's say you have a lot of view controllers that have a map in the behind. You can have like a child view controllers. Child, is not parent and child, not subclass and superclass. So the child is like, let's for example, the map. And for example, each of your view controller have two childs. The map in the background and something in front, right? Does it make any difference? Or is this, I mean, like the traditional way of doing composition before Swift in Objective-C?
Yeah, on the child view controller organizational question, I'm not sure. I'd have to think about that. I did omit some stuff from these protocols just because you have to get way too deep in the weeds of how we've implemented stuff before it would make a lot of sense. But I think in our case, having the mapped view controller as the parent view controller made a lot of sense because we didn't have to deal with the churn of moving that around since it's pretty much omnipresent in our app. Does that answer the question? Or what was the second half of it, I guess?
I just say is it more advantageous or it's just basically the same but different way of writing?
The protocol part or the child?
The protocol versus the traditional way of, let's say the map is the child number 1 and the other one is a child number 2. Because when you present, right, you was comparing inheritance versus protocol, right? I think, how about comparing the traditional compositions versus the composition that you do via protocol?
Right, yeah, I guess so the other goal that I mentioned was to try to get a lot of that logic out of view controllers, and by keeping it in protocols, we can do that. That also opens us up to some nice testability benefits as well, since it's super easy to just pull those protocols in and not have to worry about the overhead of dealing with the view controller. I think that's another big one. Yeah, I'm not sure. I mean, I guess some of these are also may come down to personal preference, but I think the protocol extension way of doing things has proven to work out pretty well for us. It's just from a code organizational standpoint as well, if nothing else.
Okay.
Yeah.
Thank you very much.
Yeah, thanks.
Hi, I have two questions actually. So the first one is when we use protocol extensions, right? The protocols are generally quite small, and over time you accumulate a lot of protocols. So how do you organize them in the project? So second question is, because of the protocol extension, right, it becomes a lot harder to test the view controller because normally if it's using objects to do the abstraction, right, you can just stop out the object, but then now you are using protocol, so how do you do the testing for the view controller?
Right, so the testing for view controllers, that's a really hard problem that we have a hard time with for a lot of reasons. We actually had a discussion about that this morning because trying to actually do UI tests on our app is pretty difficult because there's no way to really use it without having both a passenger and a driver in sync, which also obviously can't be happening on our production servers. So we have a lot of problems with that, and we haven't really found a great way to solve that. We're kind of hoping to do some other UI testing stuff, but yeah, that's a good one. I'm not really sure about what we're going to do about that long term. Right now, we lean a lot on our like a manual QA testing team to like notify us of kind of behavioral regressions. But yeah, I'm not sure long term. The other part about organization. So I guess since we tried to keep these protocols pretty small and focused, a lot of them can be specific to like a certain portion of our app, like maybe unintentionally, but it still ends up being a little bit specific. Like we'll have protocols that are used in 5 view controllers, but they're only used in a certain stage of the ride or something like that. So we kind of like group those logically with kind of a similar way you would group view controllers to keep them organized. Although, like I mentioned that we have like 120 or something, it does get pretty difficult to kind of track down the protocol that you actually need to use. That's a tough problem right now. I'm not sure what we're going to do about that long term. I think right now we're kind of just relying on the fact that enough people have enough knowledge of the code base to kind of spread that around. But yeah, I'm hoping that we can think of some ways we can solve that from a tooling perspective as well, I guess.
Thanks. Because currently we are also having this problem. So when a newcomer joins, then there's like tons of protocol he needs to know, and then what is available to him, and yeah, it gets quite difficult for him to learn.
Yeah, we distribute a lot of that through code review, but yeah, I would love to have some ideas about like creating some tools that would maybe help with some of that knowledge dispersion, I guess. Yeah.
Okay, Ken, thanks.
Thanks. Cool.
That was good. Thank you, Keith.
Thank you.